what we're going to do now is we're going to find out how we can use trigonometry to solve for angles in a right triangle. It does look like night. So using trigonometry to solve for angles in a right triangle. Now if we're solving for, if we've got a right triangle, so let me draw one here. You'll always know where the 90 degree is. And you want to find one of these angles. Let's say we're trying to solve for this angle, and you know that this side is 10 and this side is 15. The first thing you're going to do is you're going to think about your definitions. You're going to write them out. SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. And then you're going to label the angle that you want to find, highlight it, and label the sides that you know. What's the 10? Opposite, adjacent, or hypotenuse? It's opposite, because it's right across. Where's the hypotenuse? Always opposite the 90. So this is my hypotenuse. I'm going to highlight those in yellow because those labels go with the yellow angle that we're talking about. So now if we know the opposite and the hypotenuse, which one are we going to use, sine, cos, or tan? So, because opposite and hypotenuse, so we set up our definition. Sine of the angle, which we don't know, is equal to the opposite side, which is 10, over the hypotenuse, which is 15. Then in order to find an angle, we have to do the opposite of sine in order to get x by itself. The opposite of sine is sine inverse. Type that into your calculator and see if you get the same angle as I do. 41.8 degrees. Now, every time we solve for an angle, we're going to work through the same process. So here's another example. Draw a right angle triangle. There's a right angle triangle. Let's say you want to find this angle this time, and you know this is 7 and this is 12. Write out our definitions. Usually as soon as you start a trig test, you write this at the very top of your paper so that you have your definitions ready to go. Now we want to find this angle here. The 7 is what? Opposite. The 12? Adjacent. Adjacent. Those ones are what go with that angle. So which trig function are we going to use to set this up with our definition? Tan. So tan of angle x is opposite 7 over adjacent 12. The opposite of tan is tan inverse. Go to our calculator, see if you get the same answer as I. 30.3 degrees. We'll do one more. So here we have our angle. Let's highlight that one. Let's label our sides. What's 24? Opposite. 7? Adjacent. 25? Hypotenuse. This time we labeled all three sides because we knew all three sides. So now if we go to our definition, which one are we going to use? You can use any one of them because you know all three sides. So let's say you decided to use sine. So then you would say sine of x equals opposite over hypotenuse. So x would equal sine inverse of 24 over 25. Okay, I would like someone to do that on their calculator. I want someone else to say, I chose cos. So cos of x would equal the adjacent over the hypotenuse. So opposite of cos is cos inverse. I'd like someone to type that into their calculator. And finally, someone else decides to use tan. So tan of x is opposite over adjacent. Opposite of tan is tan inverse. Okay, someone who did sine, what did you get as your angle? 73.74. Someone who did cos. Someone do tan? No one did cos? Anyone do tan? I'm waiting. Did you do cos or? What did you get for tan? Or what did you get for cos? Same thing. Nice. So when you have all the information like we did in this question, it wouldn't matter which one you chose because they'll all give you the right answer for the angle. Sometimes this one's confusing because you have too much information. So any of them would have worked. It almost was easier in this last example where you only had the opposite and the adjacent because then you knew you had to use tan. But this is how we do all the questions for solving angles. You look at the information that you're given, you label your sides according to the angle you're trying to find, then you think of your definitions of which one makes sense to use. And then you can solve any angle in a right triangle with this amount of information.